Secondly, I want to remind everybody that this session is being recorded, so you will be able to access it again in the future, as well as the parallel track that is going on right now in track 1. Those links will be sent to you roughly within a week of the end of this day. And so if you haven't heard from us in a week or so, please go ahead and let us know, and we'll make sure that you get those links. Finally, I will call attention again to the question area in your control panel. If Andreas says something as you're going along and you're curious about having him expand on something like that, go ahead and drop that question in now, maybe even put down what slide you were on or something like that. If you want to go back and visit that, go ahead and put those questions in. We will save most of those questions till the end. I am moderating those questions at all times, however, so if there is something that I think needs immediate addressing, I will let Andreas know about it. Otherwise, we'll wait till the end, but please go ahead and put your questions in as you think about them. Now, Andreas is the managing partner of the Semantic Web Company. He's experienced with large-scale semantic technology projects in various industry sectors, and he's responsible for the strategic development and product management of Pool Party Semantic Suite. And he's been a pioneer in the area of linked data and the semantic web since 2002. So I am really pleased to have him here talking to us about taxonomies. I think, Andres, you wanted me to go ahead and start with the poll about people's experience with taxonomies. Is that right?
Yes, Dawn, that would be lovely.
Okay, I'm going to go ahead and launch that poll just to get started. Just that question of have you ever created a taxonomy on your own? What kind of experience does the audience have right now? Okay, it looks like most people have voted here. So about what I would expect, Andre, I'm going to close that and show the results. The majority of people, I think that's why people are interested in this conference, the vast majority of people have said, nope, they have not yet created a taxonomy. So I think they're here to learn from you about how to do so. So do you want me to also then show the second poll as well?
I think we can do that probably at the end then.
Okay.
I think that's already quite interesting, and yeah, thank you very much for the introduction, Dawn. And I'm really happy to be here today with the audience, with you, and good morning, good afternoon, wherever you are. And actually, the result is very interesting, and I would like to start with a provocative hypothesis, because I believe every one of you have already created a taxonomy in his life or her life, but probably not, you don't know it. You haven't recognized that you've done it, but our world is full of taxonomies. Your living room is full of taxonomies, your kitchen is full of taxonomies. Everywhere where you bring order to your life, to your daily work, you build taxonomies. But of course, in a digital sense, probably it's something new to most of you. At least that's what the poll is saying, and that's the reason I believe I was invited to give you a little bit of an idea how taxonomies can help you as a cornerstone for semantic information management. So that's the title. I would like to start with a quick agenda, a quick overview of that, and then introduce myself. So I'm going to talk about taxonomies in the context of linked data. That's going to be the starter. Next step, I'm going to talk about how and why to embed semantics into structured content, and also a little bit of why you should do that with web content. Then I think one of the typical questions always is, okay, taxonomies, I believe they are helpful, but how can I manage to do that? So is there a way to do that automatically? Is that probably a machine could do it for me? And I really have to start with a disappointing message. No, I don't believe a machine is able to create taxonomies for you, but it can help you. And I would like to give you a quick overview how machines and human beings can work together on creating such structures and knowledge models. And then I'd like to give you a couple of use cases in which taxonomies play an essential role that really ranges from typically from search, better retrieval of documents, but can go towards cognitive computing, as you will see. So that means all the machine learning we currently discuss can benefit a lot from taxonomies and structures like that. And I hope I will be able to also explain a little bit to you how those two technologies can complement each other. And as Dawn said, please introduce any question whenever you have one into the box in your GoToWebinar dashboard. So a quick introduction based on a little knowledge graph, as you can see, is just briefly what I'm doing. I'm here at Semantic Web Company, one of the founders and CEO of the company, which is based in Vienna in Austria. We got founded back in 2004. So we are not a startup yet anymore, I would say. But what's really exciting is that semantic web technology now got really adopted finally by the enterprises mainly, which took a while, but we learned to be patient in the meantime, and we had a good way to learn from our customers over the years why or how they could apply semantic web technologies. And that brought us into a good position to develop a software which is available since 2009 in its current version 6.0, and the name is Poolparty. It's based on the W3C standards. You know, W3C has heavily worked on semantic web technologies over 15 years, and I would say the stack is complete in the meantime. Just recently, a new standard came out, which is called Shackle, which is about kind of a rules language for semantic web knowledge graphs. But that's probably another topic to discuss. Today, I will mainly talk about SCOS, which is also part of the semantic web standards family. And it's mainly designed to build out taxonomies. And the nice thing is, because it's standards-based, you can link it to other data quite quickly. So taxonomies won't live on their own anymore inside an Excel sheet or another proprietary software. No, you can link your taxonomies to other data. And that's the nice thing about the semantic web. It's all about linking data, linking people to content, linking products to interest profiles. As you can see, it's really about a more intelligent way, in a way to manage data and bring people together with information. And on the bottom right corner, you see knowledge graphs, which is yet another topic I'd like to discuss today. You can imagine somehow taxonomies are kind of a smaller and simpler version of a knowledge graph, kind of a backbone for that reason. And what you can do with them is to put together different data silos and complement those with existing knowledge graphs. And there are tons of knowledge graphs already out there. One of the most famous ones is probably the one governed by Google. Google is using knowledge graphs to index the World Wide Web. But in many industries, you see the adoption of knowledge graph technologies. For instance, pharmaceutical companies have a lot of usage scenarios for such knowledge graphs. And I will also show you quickly how taxonomies and knowledge graphs can be linked to each other and why you probably should do that. A few words about the Poolparty Semantic Suite. Already mentioned, we came to market around about 8 years ago. It's W3C standards compliant. That brings our customers in a good position not to lose anything when probably migrating the data to some other environments. So it's a future-proof investment. We have a bit more than 200 installations worldwide, mainly working with very large customers like Fortune 2000 companies. But in the meantime, we also see more and more smaller and medium-sized companies adopting semantic web technologies. Yeah, so that's a couple of facts around the product. As you can see on the right-hand side, there are several modules you can make use of, and the one I will show you also in a live demo will be the taxonomy and thesaurus management module and the ontology management, and other aspects I will quickly talk about, which is about entity extraction, text mining, text classification, things like that, which is a typical usage or use case on top of taxonomies. And yeah, so that's a couple of first ideas how to make use of a taxonomy. So I will start the story somehow from the perspective how you can develop a semantic layer by starting from implicit semantics over a rather simple knowledge, a model like SCOS, towards a full-blown enterprise linked data environment. So that's the whole story I'd like to explain in the next couple of minutes to you. So one first image or illustration I'd like to come up with is this four-layered content architecture. And most of you, of course, are familiar with the idea and the importance of having good metadata available, consistent metadata, valid metadata which is up to date. Okay, but that's not the whole story. Because what we need to introduce on top of our metadata layer is a semantic layer. Because the semantic layer is the only way to describe the meaning of the metadata. So the metadata on its own is good, for instance, to classify content. But if you want to bring up, for instance, relations between your metadata, especially the semantic metadata, like, okay, you find some topics in the content, you find some places, people, organizations, and so on and so forth, all those business objects, you could call them, or entities, or things, if you like so, are in a way related. So any knowledge domain you would like to build or come up with high quality content for is actually organized as a semantic network. At least in our brains, human beings, we tend to organize information in the form of networks. And that's what a semantic layer can provide. Not just to the people, not just to the users, but also to the machines. And in the age of machine learning, you can imagine it's good to have a semantic layer in place because you can train your models much quicker than before if you have such a semantic layer in place. And that's what I want to introduce today, this whole idea that a taxonomy is kind of the starting point for such an effort, for such a journey. So what is a taxonomy? I'd like to come up with a very nice definition of my colleague Joe Pearman from Mecon, who came up with a very pragmatic definition. Just 3 points. So what is a taxonomy? First of all, it's a way to keep track of things that are important to your organizations. So as I mentioned before, it could be anything. It could be places, professions, religions, sciences, whatever. You can introduce in a taxonomy any type of thing you like and then relate those things to each other. And as a second aspect, taxonomies provide all the names for those things at one place. That makes a taxonomy a controlled vocabulary. And a controlled vocabulary in a world which is getting more and more complex, where collaboration should take place between various departments, various places, it's more and more important to keep track of names of all the things we're talking about. A taxonomy, and that's a widespread misunderstanding, is not trying to standardize your language. Like, okay, you're not allowed to use that name anymore, you should use the other one. No, that's not the real, let's say, goal of setting up a taxonomy. It's really more about having a controlled vocabulary in place and be sure that anybody can look up, potentially, also machines, of course, what a synonym could be used, what other names could be used as synonyms for other names for the same thing. For instance, That's the second function of a taxonomy. And the third one is a way to indicate some broad relationships between those things. And broad, because of with a taxonomy, you don't get too specific at all. You would do that rather with your ontology later, but a taxonomy is a very good first step to build out relations between things without the need to get very specific. So it's also a quite cost-efficient approach to come up with a first knowledge model of a domain. And the other aspect, I think, which is important to understand, taxonomy makes your semantics explicit. And we deal with a lot of semantics the whole day. Every day we start talking to each other. We, of course, are using a lot of semantics in the background. Human beings are sense makers. We really know very much and very well how to make use of context information to understand others when they are talking to us. Still, unfortunately, there's a lot of misunderstandings in our world. And why is that? Because natural languages are extremely ambiguous. And that's because they are very universally used. You can use natural languages for virtually anything. You can describe any domain with a natural language. That's great, but it's ambiguous. If we start using standards-based knowledge models like taxonomies, semantics becomes more explicit, more standardized, machine processable, but of course, we also lose a little bit of the universality natural language can deal with. And what you see here, for instance, someone says, Suzanne observes Mike on a tower with a telescope. That can mean a lot of things. So we need to know a lot of things in the background in order to understand what this person just told me. We know, I mean, it looks like they're trivial things, but they are not. We need to know that Mike, for instance, and Michael could be the same person. Maybe in that case, we even have to know that Michael bought a Celestron, which is a telescope, just yesterday, in order to understand that it's Mike who is on a tower with a telescope, and so on and so forth. So in any case, you always need to know a lot of things to interpret natural language correctly. Text is extremely ambiguous. And so are relational data models. That's a little bit surprising maybe to some of you, but the problem here really is that such relational data models, they just work for one application, not for the second one. So all those models were designed to drive exactly one application. So the data is siloed by that. It's just living inside this box, and it cannot be reused that easily by other applications. But we're not interested in data. We're interested in the applications. And we want to reuse data as much as possible because of cost efficiency. And that brings me, of course, again to the standards-based data models provided by the World Wide Web Consortium. The Semantic Web Standard helps enterprises and organizations in general to come up with data models which can be reused and linked to others again and again. So we are really talking about a technology which breaks up silos in order to link data in a more efficient way, even with unstructured data. So with Semantic Web, and that's one of the, let's say, key advantages, you can link unstructured data, your documents, to structured data, because it's all about entities. It's all about business objects. They live in data silos, they live in text, they live everywhere. And that's what we as human beings are interested about. We're not interested in documents necessarily. They're just containers. We want to hear and learn about facts, or we want to understand what a business object is all about. We want to have, as some of them say, 360-degree view on an entity. So this brings me to a very important aspect of taxonomies and the semantic web in general. They talk about things and not about strings anymore. So we are really very much centric or centered, or the whole data model is centered around entities or things. And those have actually 3 layers. Things are live in reality. Then there is kind of an interpretation about it in the, let's say, end user's mind. And then there are a couple of symbols which indicate that we are here talking about a certain object. So they could be basically names, but not necessarily only names or strings. It could be an image, whatever. Yeah. So this semiotic triangle is really what we are struggling with the whole time as an information manager. And taxonomies help a little bit to resolve those problems already, because they introduce some explicit semantics. And here I show you a very simple model of what I've just came up with in natural language. So here you see anything was modeled as a concept, which is a thing in this COS world. And it can have a preferred label. So for instance, this entity here has 2 names now. It's Mike as a preferred label, but then there is also Michael as an alternative label. Same thing, 2 names. But the very same thing is related, for instance, to a tower or to a telescope. So here you see that Celestron is classified as a telescope and so on. And you can endlessly, so to speak, put another fact on top. You can say how much the Celestron was, when Mike was buying the Celestron, where Susan was born, how they are related, whatever. So you can really model your data as you need it for your application. There's no need to come up with a fixed schema like in a relational database from the very beginning, because as a data modeler, you never know how your data will be used later. It could be used by various applications. You never know. With an ontology, you come up with a, so to speak, another dimension. So you can classify your things. You can really come up with a clear distinction between persons and, in that case, for instance, geospatial things. And there are lots of ontologies out there you can reuse for modeling organizations, geographical databases. You know, on the web, there is a very frequently used ontology around, which is called schema.org, which was introduced by Google and other search engine providers. So you can mix those, and by this expressivity you then have at hand, you can do even other very interesting things with your data, like reasoning. So reasoning, very simple example here, could be any human being can do that, of course. If someone buys a Celestron, then he or she can use it as a telescope. And this can be modeled as following: as you say, this person buys a certain specific telescope, which is of class telescope. And if you bought it, then you can also use it. And you don't have to put anything in your database anymore. You just come up with a couple of facts around your things, and then you have your ontology, and all together can be used to make an inference, and you can reason about your data. You can ask questions to a person, and not necessarily anything is already known, but still the answer can be given because of putting together the facts in the right way. So that's what we call reasoning, and that's also a very exciting opportunity on top of taxonomies, which are built the backbone already of a knowledge model like that. And that would be the, so to speak, full-blown version of an infrastructure for managing information in an enterprise. You see, we always deal with a lot of different data silos, unstructured data, structured data. And what we are coming up with is this semantic layer I was talking about before, which you can also call the domain-specific knowledge model and the enterprise knowledge model. So it's usually a 2-layered semantic. So the semantic layer would unfold into 2 layers. So there's more the general layer and the more specific layer. Those things are linked to each other. And here you have, for instance, the Celestron, a very specific telescope, you will find in this database, maybe how much it was, and then somewhere else the Celestron is again mentioned where you see how many people are using it or which clients are using it. And then here is probably a description of your Celestron 555 or whatever, the latest version of it, and it tells you how to switch it on. So what you would like to see maybe as a product manager is anything in one place, and therefore you need to link your data, and that can be done with this semantic layer. And on top, you probably describe what a telescope is in general, how it can be used, which knowledge you should have in order to use it correctly and stuff. So that's a very simple version of enterprise linked data. Good. So that was really the first round of ideas I wanted to bring up. That's the basic of why taxonomies are useful and how they can be used to further extend it towards a semantic web in your organization, or even by using a semantic web to put together information from various organizations or data sources. In the next chapter, I'd like to come up with a couple of ideas how to use that in a content authoring process, how you can reach the goal to get from structured even to semantic content authoring, how that could look like. So why is that important? The first fundamental assumption here is that people are not looking for documents really. They are rather interested in facts and probably small chunks of information around something. So we need an infrastructure where machines can help to create links between those little pieces of information in order to give answers to concrete questions. So that's the ultimate goal. And I will show you that the semantic layer builds, again, the basic, let's say, component to come up with an infrastructure like that. So that's just once again this illustration. And now I come up with a little example. Let's assume we have a lot of different biographies of people, in that case about politicians. Think about data, maybe in parallel. Could be also kind of a collection of data documents, in that case probably not about people, but about recipes or about instructions how to deal with equipment. In any case, we have a lot of structured content in place, and now we would like to use that to be able to fulfill a couple of use cases. So for instance, we would like to provide answers to complex questions. We would like to do automatic content quality checks. So does all of that make sense, what we can find in that data? We want to extract machine processable facts from document repositories. So we want to make out of this structured content a knowledge graph automatically or semi-automatically. We want to filter and aggregate documents maybe along hierarchies. So we want to push together information which all talks about the same things. Like show me anything about political parties in France, for instance. But it's not found in the documents, as you can see. Why is that? We need a lot of information in the background to be able to answer questions like those. So here we have the biographies of, for instance, the mayor of London, the mayor of Berlin, and so on. But if we want to ask questions or give answers to questions like, which mayors in capital cities of the European Union belong to social democratic parties, we cannot give an answer based on our documents. We need to link our XML documents to a knowledge graph, to a taxonomy. Then we can do that. Let me show you how that could work. First of all, what we need to do is we have to model knowledge which can give an answer to this question. There are actually 4 sub-questions. If you want to give an answer to that question, you need to answer those 4 questions beforehand. First, you need to know what is the city a capital city? To which country does it belong? Does the country belong to the European Union? And is the party a social democratic party, or is it something else? So we need to maintain a knowledge graph for that reason. And as I've mentioned before, with the semantic web, it's not necessarily that you have to manage that on your own anymore. You find all that data, for instance, in a knowledge graph called DPpedia. DPpedia is one of those knowledge graphs you can link to your own taxonomies and your document repository. And then you have all the data linked to each other to give an answer to that question. You don't have to come up with that knowledge modeling anymore at any point. Probably there's something missing in DPpedia, which you complement with a tool like PoolParty, but then you have all the facts around your things in one place, and then you can come up with a question like that, and you get an answer. So theoretically, it looks like that, and then I give you also a concrete impression how that could look like. So this is transformed into this semantic web standard. Just very quick introduction to that. It's all about triples. A triple is a fact. It always consists of a subject, a predicate, and an object. And it's encoded in the so-called RDF data language, so to speak. You could visualize that like that. So, for instance, Michael Müller is affiliated with the the SPD, which is in Germany a social democratic party. And he is the mayor of London. So you see subject, predicate, object. And then you would like to link those several documents that can also be done nicely with RDF. And then you want to extend on that already existing data you can get out of your documents with your knowledge graph and further on with DPpedia. And you do that just by adding yet another triple, a triple, a triple. So that can be done step by step, not necessarily by writing the code. That wouldn't work, really wouldn't scale. So therefore you need a visual editor to do so. And I show you how that works. So here, hope I'm still logged in. Yep. So here is this little taxonomy I talked about. For instance, you've got people here like mayors. So here we have, for instance, Sadiq Khan. And Sadiq Khan is, as you can see here, classified as a politician. There's a little bit of a taxonomy around it. He's classified as a mayor. And here you see the link to this other knowledge graph I mentioned before, which is DPpedia. And here you find things like when the person was born and so on. And then there is this politics ontology where we have introduced facts around Sadiq Khan. So he is, for instance, he believes in Sunni Islam, he's a lawyer, he's the leader of London, and so on. And the Labour Party, where he's member of, I can click on, and I will see, okay, this has a lot of other names, so that they are all referred to the very same thing, but still they have different names. But no worries, if you find one of those in the document, it will always be recognized as the Labour Party. Again, I have a link to DPpedia, and if I look at the politics scheme, I see it's located in London. It was founded in 1900. But this fact I didn't have to model per hand. That can be fetched automatically by the link data mechanisms in place. And that's great. And we can even extract data from documents. So if I go switch over to my politician short biographies here. So here are biographies. Let's go again maybe to Sadiq Khan. Here he is. You will see here, so here is the text, and the system can automatically recognize Labour Party, lawyer, Muslim, London, and so on. And the ontology in the background says, okay, if there's a person mentioned together, let's say with a city, you can assume, if it's all about politicians' biographies, that he's somehow affiliated or lives in London at least, or is mayor of London. So you can then really come up with not only entity extraction, but even fact extraction. So that's just a quick impression how that looks like. And now all this data, of course, I would like to do queries upon. And I put that data in a triple store, in an RDF store, a graph database called MarkLogic. Some of you might be familiar with, a very popular NoSQL store, which can provide infrastructure for your data management, highly scalable, extremely reliable, can do a lot of different data models and link those. And one of those are the semantic web standards. And there is a query language in that world called Sparkle, the Sparkle query language, yet another standard provided by W3C. So you see here the Sparkle query, and it actually says nothing else than show me all the mayors in capital cities of the European Union, and you run that query and you get those two mayors. And why is that? Because I already did the Brexit here in my little model, and I will put England now or the UK back to the European Union. So I just click on European Union and drag and drop United Kingdom back to the European Union. So now it's again a sub-concept of the European Union. I just push that into my MarkLogic store. That's one simple action here I take. And I go back to my query console and rerun the query. And now I have Sadiq Khan here once again, because we restrict down to a certain regional area, which is done here basically in this section of my Sparkle query. Of course, that's very technical. You can put a nice user front end on top, but this is the infrastructure in order to link your documents with a knowledge graph to give answers to your users to complex questions. So it's all about the query answering machine, which you have seen here in the backend. I have to admit it's not user-friendly yet, but that's a different story. Good, so MarkLogic and Pool Party, just a few words about that. Nicely integrated, you can use both technologies together to build out your own semantic web infrastructure. I want to show you another demo now, which is about semantic content authoring. So this time I would like to switch over to a content authoring environment called Font2XML. Font2XML is provided by one of our partners, a company based in the Netherlands. Their name is Leones, and they have done this great piece of software. It can be configured for any, let's say, XML schema to follow that. Dita would be one of those, as you see that in front of you, but it could be potentially any other. And now this content here you see in front of you is potentially linked to a taxonomy, which is operated in the background. So there's a pool party server in which you maintain, in that case, a taxonomy which is related to health and food and nutrition. And if you now, let's say, come up with a step-by-step approach how to cure a cold, you see here already things are highlighted and that can be demoed live. I could say, okay, step 4 maybe is don't take any antibiotics, rather, I think I wrote that wrongly. Now it's underlined as you see, rather go to sleep. And you see the system recognizes things automatically. And now I can do a right click and it will come up with suggestions. You could even put there a more specific one. So it says, no, don't take any anti-tepronemal agent. Sorry, I cannot pronunciate it correctly. And put that here, and here with sleep maybe. I just say, yeah, that's fine. I take that. So, and now it was this string was now turned into a thing. So that was exactly what I said before. So I'm no longer deal with literals or just letters in my document. I really now have a link to my thing I describe in my knowledge model, in my taxonomy. And by that, I can do a lot of things now with my content. So the content basically becomes really actionable. You can use the content for many, many different things now. for content recommendation, for query answering machines, for coming up with a personalization and stuff. And also at the time when you create the document, you see you benefit a lot because the system helps you to get more specific when you write something, or it can provide you with alternative names. It will recognize synonyms and help you with probably a different, using another word to be more in a way consistent when you write it, for instance, a technical document. And you can also click on those, and some of them, so here for instance you see the preferred label, some of those even have a maybe definition or an image or whatever. And also in the XML code you would find now not only just the literals but really the references back to the things. So in that case, by the way, we were using the mesh thesaurus, which is popular in this industry. And when it comes to semantics in web content, that's also interesting, very similar to what I've just shown. It's probably a different schema, a different ontology which might be used. As I've said before, schema.org is extremely popular and frequently used, as you can see up here. So here, schema.org was used to mark up certain areas of your text. So here a recipe, for instance, is described, and Google is using that, of course, to index in a more precise way your content, and it is able to display it in a different way. So it's good for you as a, of course, publisher if you use such semantics in the background, because you are highlighted by Google, and you can even use DPpedia, as I mentioned before, for disambiguation. So if you annotate your strings with DPpedia resources, you more or less convert it into a string, and then Google will rank you higher. That's also a well-hidden feature of how how Google is using semantics in the background to do the indexing. So, and then last but not least, of course, the question always pops up. Great, I've seen what the benefit could be, but how can I create such semantic knowledge graphs? It's not possible. We don't have people in our company. It's too expensive. We don't know where to start. All those questions. And if you look at a technology like Pool Party, you will see that you have several ways to create semantics. It's not just the manual, handcrafted way, as I have quickly shown to you with this politician's taxonomy. Many of such semantic data can be created automatically. I just want to come up with a couple of other options you have in Pool Party. So for instance, power tagging is one of those, where you can add metadata on top of your documents automatically by extracting entities, doing semantic enrichment. You can fetch data from virtually anything like a relational database, a web API, and transform it into a semantic knowledge graph. You can use, therefore, Pool Party unified views. And yet another module which is interesting is the machine learning component of Pool Party, which learns from documents. So it can create kind of a first draft of a taxonomy automatically. But as I've said before, it doesn't substitute a subject matter expert at all. It just helps you to generate or come up with new term suggestions. So in that sense, it's a machine which learns constantly, which pushes back suggestions into the knowledge model, into the taxonomy, where several roles are involved. Maybe I quickly show you that. So here, for instance, if I switch back to my so-called corpus, I can find here suggestions of what I might include in the next round in my document, in my taxonomy. I can then double click on that. If I click on that here, I will get suggestions how that's related. So in that case, Warsaw should be the right place to link with this person here, obviously. And it's about an election and a civic platform and things like that. So Pool Party really helps you to extract new terms to turn them into a thing in the next round. So that, I think, was already done, the demo of how the semi-automatic creation and maintenance of knowledge graphs could look like. That was a very quick intro into that. Just a quick summarization about that, how that plays together. So those taxonomies help you to entity extraction from any kind of data, also unstructured data. It's transformed into a graph. All that together with the taxonomy can be stored in a triple store, in that case like MarkLogic. Of course, there are also other options potentially. And then you can push or put a nice user interface on top and do analytics and search over your data. And that data can come potentially from various data sources, all linked to each other. In that case, the Pool Party Unified Views component could do that for you quite automatically. And if we go beyond semantic search, which is most probably what you would like to have in place with a software like SharePoint, that's a typical case. The search in SharePoint is something which benefits a lot from some enhancements. But still, if you push that into a triple store and link it to other knowledge graphs and taxonomies, then you can use those taxonomies to do queries over your data. I show you an example, a quick one. So here, for instance, we have around about 27,000 documents collected from the World Bank. All of them were in a nice XML format initially. And then we started to link those automatically to, in that case, two different taxonomies, a geographical one, a topical one. That one is maintained by the World Bank itself. And again, those, in that case, geographical entities were linked to the DPpedia knowledge graph. And by that, we can do even more sophisticated queries, like show me all the documents of countries or mentioning countries which have more than 50 million inhabitants, for instance, things like that. So let's maybe do a quick example. So here you can use that filter, which is derived from the taxonomy quickly, and you can come up with things like, okay, show me all documents which are about green cities maybe. So you get this bunch of documents here, and also quite nice is a little info box. You see here other names for green cities maybe. You get the documents, you get related topics like green growth. You can click now on green growth and further drill down and maybe get the document about Thailand and the partnership for market readiness. And then you get similar documents. Again, this is something you can calculate on top of a taxonomy in a more precise way. That's also interesting when you do a research around a certain topic, and you see quickly also automatically which other topics are inside this rather large document. So you get a quick overview of topics mentioned in it, and in that case also geographic regions. So that's a quick example of how taxonomy can be used to retrieve documents in a more fashionable way. We also talked about the question answering use case, so I think we don't have to go into details anymore with that. But just as a reminder, I've shown you this semantic search over World Bank documents. Now you can try that out automatic on your own if you like. It's online, so try it out, please, if you want to play around a little bit with that. And then last but not least, I want to come to a last use case, or actually nearly the last use case, which is about the semantic guided search at Wolters Kluwer. Wolters Kluwer, is a large publisher in legal and other areas. And what I like very much is the way they describe the benefit of taxonomies and semantics, because they don't use it only for document classification. They use it for a better user experience in all stages of document research. So it's used to guide a user before searching, to find the right search terms maybe, then guide after searching to filter out documents, and then also to guide users inside a document. And the precondition to be able to do so is that the document is at least semi-structured. And of course, Wolters Kluwer is using XML heavily for the publication process. And since a couple of years, they're now using semantic knowledge graphs to link their content pieces all together in a very consistent way. And the ultimate goal here really is to give answers to such questions like, what is the deductibility of vehicle costs? And that can be done by several steps already during the content authoring process. So any content piece is classified. As you can see, for instance, here, this part of the document can be classified. Here is a taxonomy in place. Here, the pool party server helps to come up with the right concept suggestions to do the annotation semi-automatically in the background. And that's then really the infrastructure to give the client such a user experience. And last but not least, here is a last example of how semantic content authoring could look like. It's an example provided again by our partner Micon, the Micon Chef, based on Font.xml and Pool Party. So there are recipes in that little example, which were created inside Font.xml. It was nicely connected to a taxonomy in the background, as I've shown you. And as a result, you get an application like that one. So let's go to recipes maybe first. So here you have, for instance, the strawberry coconut shaved ice. That's a very nice one. And what you see here is maybe you're a vendor of such equipment. You need to create such great food. And now you would like to really embed it nicely in your content. So the ice shaver disk is something which is linked in the background to the same concept of your taxonomy as the recipe. And now the system can pull out such links automatically. And you can show the information around this product. And again, you could go back to all the recipes where this product should be used. And that's done automatically, of course, in the background. You don't have to link your product to your recipe anymore manually. You link it rather to the concept in your taxonomy, both of those content pieces, and then you have triangulated, so to speak, those three things, and that's done automatically. And that can then really happen on a larger scale. Quick outlook. One sentence here, semantics can be used really alongside the whole content lifecycle, from creation over content linking, publishing, retrieval to better content quality management. There are two integration scenarios. The simple one in which you annotate your digital assets, could be, of course, also images, not only text, inside your silo. You already benefit a lot from that. But the link data and the semantic web architecture actually goes beyond that. And here you have to have a graph database in place, which is kind of the machine which will help you to link all your different data silos in a most consistent way. Those are the two options to push semantics into your content authoring processes. So that was it. There's a Pool Party Academy. You can learn quickly based on self-paced e-learning modules, how semantics can be used. There's a free module for all of you, which is about semantic web in general. So there's not a lot about Pool Party in this first learning module, but if you want to learn about that a bit more in detail, there's also track 2 and 3. You can try it out online on our website if you like that, and you can meet us at several events, upcoming events in Amsterdam, in London, in Vienna, and in Washington. So would love to talk with you in detail about your use cases. That was it. Thank you.
Thank you, Andreas. Again, a reminder to everybody, if you have any specific questions, we have just a few minutes left, so you can go ahead and type those questions into the question area. While we wait for other questions, Andreas, maybe you could just, you presented a lot of, I think, very detailed information, and, we know from the poll at the beginning, nobody's really started creating a taxonomy, or they haven't done one on their own before. Really, what's the right starting point here? We're kind of at this point of maybe we understand a little bit of metadata, we understand that layer, but to move into that next layer that you're talking about, how do you recommend people get started?
I think it's really about use cases first. We frequently have seen, without any use case in mind, it's hard to motivate someone to learn more about semantic technologies. But I think that was really happening in the past few years. A lot of people got a good feeling why that's somehow important. And now the next step really is to map those two things. And I would really recommend to learn quickly about the basics. So learning about costs and taxonomies, how they are structured, is not a big deal, to be honest. That can be learned quickly. I think the rather tricky part then is to come up with a process which is really somehow manageable inside an organization. I know that most organizations do not have a role already in place which is clearly defined as a taxonomist or an ontologist, so that has to be somehow started from scratch now in many organizations. But then after a while, when use cases got really visible and the benefits are clear, then usually organizations really start to invest into such kind of information management approaches. So it's a little bit of chicken and egg problem currently, but step by step, little first use cases without a lot of risk, and then people learn, and then they like it, and then you can introduce that more and more at several points in your content processes.
Okay, I'm sorry about that, but I just got kicked out, so I just joined back in. I still don't see any additional questions, however. So, since we are at the top of the hour, I just want to thank you, Andreas, and thank everybody else, and remind you to come back into track 2. I will quickly just remind you what is in my track. Here. So back in a half an hour for either in track 2 in this track, you will see Jamie from IBM talking about practical taxonomy and SEO solutions, or in track 1, we will see Wendy talking about time managing your taxonomy. So thank you all for that. And with that, I will call this the end of the session.